So chapter 14 and 15 are on the universe and the solar system. So stars are born in clouds of hydrogen gas and dust in between other stars. So what gravity does is it pulls these huge masses of hydrogen gas together into a protostar. So the mass of the gases eventually become the star once the gravity activates on it. And so the protostar contracts, becoming increasingly hot at the center and eventually reaching a temperature high enough to start nuclear fusion reactions between those molecules and atoms. So the pressure from those hot gases balance the gravitational contraction, and the average newborn star will shine for billions of years before it eventually dies out. So these are how stars are born. All right, so the average star has a dense hot core where the nuclear fusion occurs. It releases radiation, and then a less dense radiation zone where radiation moves outward, and then a thin convection zone that's heated by the radiation at the bottom. So then it moves to the surface and emits light to space. So that's what we see in the night sky when we see the stars twinkle. It's just a radiation reaction going on inside of the core of that star. The brightness of a star is related to the amount of energy and light it's producing. So the size of the star and the distance to the star also matters when it comes to measuring the brightness of that star. So the apparent magnitude of the brightness of a star as it appears to you is called the apparent magnitude. The To compensate for differences in brightness due to the distance, astronomers usually calculate the brightness that stars would have at a standard distance, and this standard distance is called absolute magnitude. So your absolute magnitude is an expression of luminosity. So it's the total amount of energy radiated into space each second from the surface of the star. So stars appears to have uh, different colors because they have different surface temperatures. All right. The life of a star consists of several stages. So the longest of which is the main stage after a short time as a protostar. So again, protostar, that's the beginning phase. That's when the hydrogen gas and the different molecules are pulled together by the gravity. And after using up the hydrogen in the core, a star with an average mass expands to a red giant, then blows off the outer shell to become a white dwarf star. And this is supposed to be E right here. Let me save that. Okay, so that slowly cools off back to a black dwarf. So the hotter it is, the brighter it shines. It eventually blows off, or it heats to a point where it can't be heated anymore, and then it cools off. All right, so that's what we call a black dwarf, when it's completely cool and it's not giving off any light at all. So the blown off outer layer shell forms a planetary nebula, which disperses over time to become the gas and the dust of interstellar space, or it can form into a different star. So for more massive stars that collapse into neutron stars or black holes, this happens after a violent explosion, and we call that explosion supernova. All right. So this is a example of the life cycle of a star. Um, we always start out the same with different gases and particles of matter being pulled together by gravity, but the ending can also be different. It can turn into a white dwarf star. It can be a neutral star that doesn't really give off, any light at all, or it could totally collapse on itself and produce a black hole. So let's determine each way it could go. All right, so if we have an average star, when it's going into the dying out stage, it will turn red. All right, so we can go from an average star to a red giant. That means those layers are starting to peel off. You can have planetary nebula, so it kind of like just starts to blow off steam and becomes a white dwarf. All right, so a white dwarf means it's cool now. the star is no longer hot. All right, so or we could go to a massive star, and it turns into a red supergiant. So it has this orange glow right here. If it explodes, it will become a supernova star, and it can either cool all the way off to a neutron star, or it can collapse on itself to become a black hole. So galaxies are the basic units of the universe. So the Milky Way galaxy, that's what we're in right now. It has three distinct parts. It has the nucleus. So the nucleus is the center part. It has the rotating galactic disks. So these are the arms, and then it has the galactic halo, which is kind of the light that surrounds all the stuff in the middle. The galactic disk contains subgroups of stars that move together as clusters. And then the halo contains symmetrical, tightly packed clusters, which includes millions of stars called globular clusters. All right, so this is our Milky Way galaxy. In the middle, you see the nucleus. So this is the centerpiece. The spiral arms is the extensions from the nucleus, which is in the centerpiece. So here, this line, this blue line points to the sun, and it's located inside of a spiral arm. So we are not in the center of our own Milky Way galaxy. We are in the arm, all right? We're just a piece of the arm. So more about galaxies. All the billions of galaxies can be classified into groups with four structures. So elliptical, spiral, Barrett, and irregular. So evidence from astronomical and physical clocks indicates that the galaxies formed about 13 to 14 billion years ago, and it's been expanding ever since from the Big Bang. So the Big Bang theory describes how the universe began by expanding. All right, so that was chapter 14 about the universe. Chapter 15 is on the solar system. So in our solar system, we have the sun, Mercury, Venus, Earth which is where we are, Mars, Jupiter, Saturn, Uranus, Neptune, and they used to count Pluto as a planet, but now it's not. So we can kind of leave off Pluto now. So the planets can be classified into two major groups. We have terrestrial planets and we have the giant planets. So the giant planets are bigger than the terrestrial planets. So our terrestrial planets include Mercury, Venus, Earth, and Mars. The giant planets include Jupiter, Saturn, Uranus, and Neptune. So all of those planets are bigger than the terrestrial planets that I just listed. Comets are other objects that float in space. Comets are porous aggregates of water, ice, frozen methane, frozen ammonia, dry ice, as well as dust. As it approaches the sun, the increased radiation evaporates that ice and pushes the ions and dust into long visible tail. So sometimes you think you're seeing a shooting star, but it could just be a comet melting as it gets closer to the sun. Asteroids, those are rocky metallic bodies that are mostly located in the belt between Mars and Jupiter. So that's what we call the asteroid belt. That's where most of the asteroids that are in our solar system, that's where they are mostly grouped together. All right. Meteors, so the remnants of comets, fragments of asteroids, and dust are called meteoroids. So the meteoroid that falls through Earth's atmosphere and melts to have a visible trail of light and smoke behind it is called a meteor. A meteoroid that survives the trip through the Earth's atmosphere to strike the Earth's surface is called a meteorite. So most meteors are fragments and pieces of dust from comets, and sometimes they mostly disintegrate before they hit our atmosphere. Most meteorites are fragments that resulted from collisions between asteroids. So again, most of the asteroids in our solar system are between Mars and Jupiter because that is the asteroid belt. All right, and that is the gist of chapter 14 and 15.